Thank you. Up next is Mr. Beau Perry from Brevas.
All right, for the sake of everyone's blood sugar level here, I'm going to try to compress some of this and advance it a bit, but definitely want to thank United Nations and the United Arab Emirates ID Authority for extending the invitation to present today. And the first International Open Data Forum, I think, is a huge success. A lot of great revealing information, but I wanted to speak more pointedly towards some of the problems and our particular solution towards something that we have established as a major problem in today's authorization paradigm, and that is the username and password. There's nothing like necessity to force a solution, and back when username and password were instituted, Bell Labs knew it was flawed. And all it takes these days is someone with some simple hacking tools, and they have the ability to get in and salt and hash a database and walk away with passwords. That's not a good thing, especially for consumers in large industries. So with the explosion of IoT, Internet of Things, we need a more meaningful approach towards account binding and man-and-machine binding. Average person is captured on 38 closed network camera systems a day. And so my advice relevant to the privacy scenario is stay at home if you want pure privacy. On the other hand, I think Tesco learned some valuable lessons in privacy in that they had camera systems at pumps identifying people and relating them to purchasing habits. And the consumers found out after the fact. And there were some serious repercussions there. One of the solutions towards that is allowing the consumer to know that the camera on their smartphone is in their pocket and they control it. If they're able to use it as a phalanx, which is a defense mechanism as well as an offensive mechanism, it allows them to crawl ahead of the privacy concerns there. So Brevas stands for Biometric Reflective Identity Verification Authenticator System. We operate a decentralized team around the U.S. engaged in deep research and development, and we're currently pedaling on several beta tests with large Fortune 500s. We employ 7 engineers, and we have deep talents in artificial intelligence and machine learning, the crux of all of this data. The components required to make all this stuff relevant, fast, and robust exists in that GPU-based processes, cloud or native. We have a concept that users should be permitted and entitled access based on the relevance of their access controls given by something they select in an individual app or a systems administrator. We call it augmented authentication, and we want to remove some of the obvious challenges like human memory, password complexity, password rotation, and innate challenges therein. Augmented authentication is a broad term with differentiating levels marked by computer vision, ambient persistent data, along with server-side secrets from sensors off the smartphones that all of us carry. We can use this criteria in a varied input-output scenario to register, authenticate, and encrypt and decrypt. It's all based on the use case scenario, and every time we sit down with a company, we get about 40 of those per company. So condensing that is the name of the game. Heartbleed was mentioned yesterday, and again, there seems to be a heightened sense of awareness for replacing this broken system. Gartner, as well as Forrester Research, did a study to extrapolate the granular cost of resetting one password in a normal-sized enterprise. 20 to 50% of all help desk calls were password resets. I don't know if these companies are capturing this in their operating expenses. I know they're not capturing the opportunity cost of their workers that are out of the game because they can't access their emails. So while a large company is looking at $70 per employee, there's a lot of operational expense there that definitely, I think, through aggressive addressing of new systems can get ahead of that. And the advent of open source and open data makes better authentication methods more necessary, and the access-based resources in place to open and share this data is important. We find it paramount to make this priority and create smarter systems and more cost-effective access to database warehousing entities. For example, the anticipated declassification of U.S. government documents changes from the 50-year to the 25-year term. It's what's known as the avalanche or the tidal wave. And we find it from an engineering standpoint a lot more cost-effective to store one document and have multiple levels of access versus however many hundreds of thousands of documents for each user that pulls it. A company named Teradact is a company that we are working closely with to address this problem in a cloud-based scenario where we provide different and varied levels of permission access. We can mark up the document based on who's looking at it and solidify the identity awareness factors with that deep machine learning, and on GPU and the quad-core processors do it very fast. Our technology uses both native and cloud distributed real-time identity capture tools, some of it open source, like OpenCV. There are other libraries that we utilize dependent upon the use case scenario, but we take our own algorithms and put them on top and blend different factors dependent on the use case. Again, we're trying to achieve reduced expenses for companies and their system admins to rapidly recapture hidden IT expenses related to account recovery and permission access. The reasonable per month seat license, like most open source software, is minutia compared to some of the inherent problems that someone with a password access can definitely do a lot of damage. One thing to note is that in most companies, you're given an access badge and your picture is taken. That data is sitting there and it's not necessarily being utilized the best way possible. So that means that the HR department is responsible for the enrollment of the user, and that the user can't have control over that, especially in a government or enterprise scenario. So there is some amount of truth that needs to be hashed out in the initiating segment of this, but in the government arena, cost sensitivity is so intensely scrutinized that the data being collected, used for both internal and external use, can definitely be looked at with privacy and security being paramount concerns. So if you look at some of our technology that we have patent pending on right here, we predate Google by 4 months on some of this stuff. It's a great example of innovation coming out of the ethersphere. We're a small company, nowhere near the size of Google, but we also know that Google started in a garage as well. As I mentioned before, the ability to register and authenticate and encrypt and decrypt a message or any binary code in transit becomes a strong method in this arena. So we ask the user to prove they are who they say they are. Some of these methods that we use that are innovative and unique are different liveness detection modules, contextual cross-checking, which is becoming a key buzz term, the context of smartphone geolocation awareness, and then user identity awareness with the server-side secrets. Again, we use different levels of flashing lights sometimes, reflections, and other almost gamified movements on the screen. So I can't get into much detail there, but I think you can extrapolate some of what I'm discussing, and I hope tomorrow to shed some more light in the brainstorm session. So several of these high-level cryptographic modules that we work on, we've been in discussions with NASA. And NASA is very focused on putting robonauts next to astronauts. As we practice colonizing Mars on the moon, we need to make sure that the robots aren't knocking our astronauts out, and they need to understand who is the master. And so this Internet of Things will evolve towards that, but it's all these devices in this early stage that we care about now. A great example is Dick Cheney's pacemaker. They had to get rid of or turn off the wireless password functionality because they were afraid that someone might hack it and give him a heart attack and kill him. And again, this is a scenario that it's drastic and on the edge of the possibilities, but we need to have a method in place to stop that, period. And this is a way for all of us to be able to control all of these appliances in our house, so we don't have the refrigerator. This was an interesting discussion yesterday. The refrigerator fighting with the dishwasher, right? So we boast that our authentication encryption that runs asynchronously is robust and quite simply the future of man and machine binding. As for the future, we also see great opportunity in robotics and embedded systems. And as man and machine work closer together, we find that new tool sets coming out like Intel's perceptual computing SDK will help pave the way for other small companies like ours to engage in this perceptual model of computer vision, which I think will start to become very important, especially on the smartphone level, in the next 5 years. So we see the smartphone as being a new credential. Cards with chips, like the CAT card, there are some inherent flaws to that because at RSA conference, we just see people adding more hardware to systems, and we don't necessarily think that that's the answer. We want to leverage something that people already have. And so I invite you to learn more about our company, brivas.org, and I'm happy to share with you any of our information on the team members. And I want to extend a special thanks to the United Arab Emirates ID Authority. I think that you guys are definitely showing some awesome innovation and aggressiveness in this field, and I salute that. Thank you to Mr. Rich Kirby and the United Nations for being the brainchild of this event, and we're happy to be part of the inaugural voyage. And I'd like to play off some of the words yesterday that I heard, and manifesting that you know, the concept of all of this is as if a ship is ready to set sail, and I think that you've started your course, and we're happy to hop on board and see if we can help. So I appreciate everyone's time, and that's the abbreviated version. So thank you very much, and on to the next one.
Thank you, Bo. All right, so for our last presenter, Mr. Karel Bannerhorst from SAS.
Thank you ever so much. Can everyone hear me? I'm not used to these static mics. I usually have something that allows me to roam because I've got a bit of ADD. Can everyone hear me? Very good. Thanks a lot. Assalamu alaikum. Thank you very much for this, because this really opened up my thinking. This conference opened up my thinking to talk about my second favorite thing in the entire world, and that is data. Data, we love data. I mean, I personally love data. I love all data. I love big data. I love small data. I love fat data. I love tall data. Any data. In fact, I adopt data. Any data that potentially or has the potential to tell me a story, I will adopt it. I want to take this data and use it so that I can learn more. I want to know more. And this is one of the initiatives that's really going to allow us to do this, is open government data. But remember, there's open data, and there's open government data, and there's social data, and there's your internal data, and all of them have something in common. They want to tell you a story. But the only way you can tell a story using data is if you have certain things in place. And that brings me to my real love, my first love, my passion, and that is mathematical analysis. Now, when I say mathematics, I can see everyone going like this. Don't be scared. Mathematics is not that terrible. Mathematics is modern mathematics is kind of like launching the rocket ship in Florida. You don't need to be a rocket scientist to push that red button after they said, go, go, go. All you have to do is press the button, and modern mathematics is kind of like that. What it allows you to do is it allows you to tell this story, bring this data in. You don't need to write the algorithms. You don't need to know how the algorithms work. You don't need to know what's going on behind the scenes. All you have to know is how to interpret the story, how to tell this story, and why is analysis and why is mathematics important? Why am I talking about that today? It's important for two things you're going to find with open government data. Two things are going to potentially want to trip you up when you start going down this journey of using data that is not your own, but potentially can add a huge amount of value. What are those two things? Number one, the data is not always useful as it is. It's not ready to tell you the story. It's like a shy person sitting in the corner, and unless you ask him the questions, you will never know whether he's clever and shy or just quiet and silly. What we want to know is, how are we going to prepare this data to tell the story for us? And the way we typically do it is by using some sort of analytical process. It's called text analytics. Think about this sentence. An elephant was born in the bathroom. Now, if I read this sentence in a newspaper, or I read it on Facebook, or I see it on Twitter, or some sort of visual display gives me the sentence, an elephant was born in the bathroom, what I'm going to do is I want to investigate this further. I am a person. I am potentially interested in this. It's a heading that catches my eye. I want to read more. If I am a machine, and I go through all of this unstructured data, what I need is that human input that is potentially going to grab this data for me. It's going to say, you know what? This potentially is going to add to my knowledge. It's going to add to my storytelling. I want this data. Text mining and text analytics will do this for you. Now I've got this sentence and it says, an elephant was born in the bathroom. I now need to put some categorization around this because I want to see whether this is an interesting sentence for me. Should it be flagged? Or should I just let it go? If I see the categorization around this data, I look at the category of bathroom, and it's okay. That data can slip through. Bathroom is okay in my safe words. But it also takes into account elephant. And typically, I don't know about your experience, but typically in my experience, elephants are not born in bathrooms. Flag it. Outlier. I want to know more about this sentence that I'm seeing. Now I want to put some context around it. And the context should now further elaborate whether this is safe or not. And the context is localized to understand the environment in which that word is used so that I can think. Elephant, bathroom, doesn't make sense. But when that appears in an area where, for instance, in Turkey, at the Turkey Zoo, the elephant room is known as the bathroom, suddenly, in context, that sentence makes perfect sense. It's not flagged. However, the data was grabbed. The data was categorized. And there was some context given to that data. And the last thing is it positive? Is it negative? Or is it neutral? Do I need to take action? Do I not have to take action? Or should I just leave it? So I need to understand all of these things on open data, open government data, because remember, it comes in strings that are typically not structured, and it's not quality, and it's not beautiful, and I don't understand it the way it is, but analytics will help me get it into a way where it is now ready to tell me a story. So this brings me to the second thing analytics has to do. It has to tell me the story. I'm now going to move on, the slide, to this. And I want you to focus only This is the wrong one. Let me just go. Oh, there we go. I want you to focus only on the yellow bit. The yellow bit, text analytics. This is the capability from an analytical perspective I need to bring in all of this unstructured data, be it open, be it social media, be it my internal data, so that I can make sense of it. All the other portions of this diagram is now the ability for me to use analytics to tell a story, starting with statistics. What does statistics do? Statistics help me understand the heartbeat of my business. It helps me detect the patterns of the past. As soon as I understand the pattern of the past, what can I do? I can see what will happen in future, so I can start doing forecasting. I can look at how big this problem will be in future, whether I need to address it or not. If I need to address it, what do? I do data mining, predictive analytics. I need these libraries available to me so that I can start making future-based decisions, and then I will optimize. This is the second story of analytics. Although I am not a rocket scientist, although I am only the person pressing the button, everything that happens once that button is pressed, is the capability set that enables that rocket to go to the moon. It should be the same with analytics. Although I don't write the algorithms, I still need all of this capability to flow through the heartbeat of this story so that mathematics can tell me the story. I do not have to know what I am investigating. I can let mathematics tell me what the story is here. I'm going to show you a quick case study, case in point. Look at this. This is a case study we did with the UN Global Pulse team. The Pulse team has the remit to monitor socioeconomic outliers to try and figure out whether things can be alleviated using open data, open government data, social media data. So what we did with the Pulse team is we wanted to answer this simple question. Does the sum of total of what we say online, social media data, does it add value to our lives or not? Or is it just big data that everyone says we should manage, but it's really useless? So what we tried to do is come up with the questions, and we decided to ask this question. Can employment patterns be predicted using what people are saying on social media? Twitter, Facebook, newspapers, all these blogs. Can I predict an economic slump? And we took data from US and Ireland. We took data from the US and Ireland for two reasons. We wanted to validate that you could actually detect the slump. So it needed validation, and the validation brings the open government data into play, because we had open government employment statistics sufficient for validation for Ireland and for the US. So stay with me, I'm almost done, 5 minutes. This is the process. This data was not ready to tell me the story. I grabbed the data directly from Facebook and from Twitter and from the newspapers, and I forced it into submission. Text analytics. I forced it into submission to be ready to tell me the story, not yet tell me the story, to be ready to tell me the story. And then I used all of these other analytical algorithms to tell the story, explore, understand, is there a problem here somewhere? Can I detect the heartbeat of this data? Can mathematics expose this to me? And guess what? It played along beautifully, because I detected three very important things. I want to skip that. I want to go directly to this one. Number one, huge increase in depressed mood conversations 4 months before a spike in unemployment. This is down to the demographical layer. I know exactly who said this, where do they live, what socioeconomic class do they fall into. I can determine a lot from Facebook, from Twitter. You expose yourself on those sources. We know this demographic information. Look what we find. 4 months before, within a 95% confidence limit. Loss of housing increases 2 months after that. Loss of or auto repossession increases 3 months after that. In Ireland, a similar story, 5 months, travel cancellations and housing situations. This is data that is free and it's open. It's social media, and this is all validated against open government data, economic statistics, employment statistics. All of this exposed using analytics, bringing the data in, massaging it, getting it ready to tell the story, and then accurately, within a 95% confidence, actually telling the story. So what does this tell us? It tells us open data, open government data, social media data is useful if you have the capability to tell a story and allow it to tell you a story. This is what we are currently measuring based on this case study. We have a 95% confidence KPI running in the UN for unemployment increase. It's monitoring all these social sources, and it's seeing that, if I see these patterns, within 4 months, I will have a problem. We have an early warning KPI for banks 6 months out of potential defaults. We have an early warning system for manufacturers of automobiles, sales of automobiles, finances of automobiles, 7 months out before the activity happens of automobiles being repossessed, etc. Mathematics is magic. It will tell you an appropriate story, but you need to be ready to have that story told, because it does not stop with monitoring. It goes on and physically tells you what you can do about it. I've not even gotten to that portion of what we can now let analytics tell us how to take action based on this early warning sign. Think, if we know 4 months out that there's going to be a problem in a specific area for a specific demographic, what we can do from a social perspective. So from a social care perspective, from a healthcare perspective, from a welfare perspective, what we can do with these early warning things. Analytics, mathematics, is what you need to tell you the story once the data is open, beautiful, and available. Thank you very much.